Hello, math students. Welcome back to our module on integer exponents and scientific notation. The lesson is called Operations with Scientific Notation. Our goal is today we will learn how to add and subtract scientific notation. The question that I want you to be thinking about in this lesson is, what must the exponents be in order to add or subtract scientific notation? All right, so in our previous lesson, we talked about how to multiply and divide with scientific notation. And in today's lesson, we're going to talk about how to add and subtract. All right, so things to know. Remember that when combining or separating numbers in scientific notation, there are specific steps that you must follow. When you are adding or with addition, the first thing that you need to do is find a power of 10 that they have in common. To do this, you will have to change the place value. And then you also need to remember that the powers must be the same in order to add. Now, something to think about is, remember when we were learning how to do fractions early on in math, and all of your teachers told you or taught you that you needed to find a common denominator. Well, the reason that you had to find a common denominator is because then they are parts of the same piece or whole, and they have like pieces, so you can figure out what to take away or what to add. So scientific notation is also the same way, because it has to be in the same place value in order to figure out the sum or the difference. So the first step that you have to do when you're adding and subtracting is you have to make your scientific notation bases the same. Okay? And remember, in order to do that, we have to have them in the same place value. So what I want to talk to you about first is, how do we add 5 million and 3 million? Well, if we have 5 million and 3 million, you know they're in the same place value because 5 is in the millions and 3 is in the millions. And when you have 5 in the millions and 3 in the millions, you just add them together because they're in the same place value, and you end up with 8 million. Okay, so if we look at that, this is really 5.0 times 10 to the 6th, and this is 3.0 times 10 to the 6th. And then because their bases have the same exponents, now we can add them. And so we would get 8.0 times 10 to the 6th. Well, that makes sense. That's very real. But what if I was going to take 5 million and I was going to add it to 5,000? How many of you believe that I wrote it correctly? I hope every one of you is going, no way, that's not right. Well, if you're thinking, no way, that's right, not right, then you are correct, because 5 million plus 5,000 does not equal 10 million. And if I write it like this and add these together, then I'm going to get 10 million. But 5,000 is way smaller than 5 million. So what we have to do is we have to make sure that our place values are lined up in the correct way in order to add them together. And so that's what I'm trying to show you, is that this way is not correct. So if you do not make your bases the same exponent, what essentially you're trying to do is to add two numbers like this. Okay? So it's very, very important that the first step that you do is you make your exponents on your bases the same value. So in order to do that, you will have to change the place values. Okay? So we're going to try one, and the way we're going to try it is by looking at this one. This one says 3 3/10 times 10 to the 16th power plus 5 7/10 times 10 to the 19th power. And what we need to do is we need to change one of them so that it has the same power. Okay, and what I would suggest that you do is, it would be easier, in my opinion, if you were trying to convert 10 to the 16th power to 10 to the 19th power. And what we would need to do that is we would need to multiply by 3 more 10s. Because if we multiply by 3 more 10s, then this would be, another 10 would make it 17, another 10 would be 18, another 10 would be 19. And we're multiplying by 10, so we have to do that. So in order to have the scientific notation where you have the powers the same is you are going to take the number that you're trying to convert, so 3 3/10 times 10 to the 16th power, and we're going to multiply it by the number of tens that we need. So we just said that we need to multiply it by 3 tens. So here's 1 10, here's 2 tens, here's 3 tens. But in doing that, what is happening over here is that your number over here has to get smaller. So we're actually going to make this into a fraction and look at it like this. So right now we have 3 3/10 times 10 to the 16 over 1, and we multiplied the top by 3 tens. So what we have to do on the bottom is we have to multiply the bottom by 1/10. And you know that when I write this, this is 1/10 because of all the work that Mr. Corrales has been showing you on the board, that when you're multiplying underneath the division bar, that's really 1/10. So let's go ahead and do that. So these are all bases of 10. So we have over here, if we multiply straight across, we have 3.3 times 10 to the 16th, and then here's plus 1, plus 2, plus 3, so now we have to the 19th. However, we now have to take 1 times 10, which is 10, times 10, which is 100, times 10, which is 1,000. So what we're really doing now is we're taking this numerical number right here and dividing it by 1,000, because it says 3 3/10 times 10 to the 19th divided by 1,000. And when we do that, you're essentially going 3.3 divided by 1,000. And can 1,000 go into 3? No. 0 is what we say no. Can 1,000 go into 33? No. Can 1,000 go into 330? No. Can 1,000 go into 3,300? Yes. Okay, and that would give us 3,000, subtract it off, and now we have one more 0. Can 1,000 go into 3,000? Yes, 3 times. So this right here is actually what your number now looks like. So now you have 0 and 33 10,000ths times 10 to the 19. But now you see that our powers of 10 are going to be the same. So then we're adding, so all we have to do is we have to take 5.7, and your decimal points have to line up just like you learned when you were doing decimal work, and then your powers line up and they stay exactly the same because now they all have the same powers, and you add them together because that's what we were asked to do. So this would be 3307, and your leading digit is 5. So your answer would be 5.7033 times 10 to the 19th power. So now we know that 3 3/10 times 10 to the 16th power plus 5 7/10 times 10 to the 19th power equals 5 7,033 10,000ths times 10 to the 19th power. And that would be how you get your final answer. So this guy right here is your final answer for adding those two numbers together. Okay? So that wasn't so bad, right? The thing that you have to remember is that converting your powers to the same power is where it's the most work. So you just have to really think about what it is that you're doing. Okay, so now that we know how to add them, let's try to subtract them. So find a power of 10 that they both have in common. To do this, you will have to change the place value. The powers must be the same to subtract. So we're going to use the exact same steps as we did up here, but however, when we get to this point, we're actually going to subtract instead of add. Okay, so we have two new numbers. We have 2 1/10 times 10 to the 8th power, and we have, we're subtracting 4 2/10 times 10 to the 7th power. Okay, so I have 8th power and I have 7th power. So what I would like to do is I would like to try to get this to the 8th power. So just like we went from the 16th to the 9th power, in order to get to this to the 8th power, all I have to do is multiply this by a 10. But remember, what you do to one side, you have to do to the other. So we're going to take that number. So here's that number, 4 2/10 times 10 to the 7th. And we're writing it over 1. we're going to multiply it by a 10, which is really not a real 10. It's actually just a 1, right? So, but when we do that, our outcome is now going to be 4.2 times 10 to the 8th, because, remember, this is 10 to the 1. So the bases are the same. Add the exponents, so that's now an 8th. But on the bottom, we have 1 times 10, which is 10. Okay, so now read what we're supposed to do. 4 and 2 tenths times 10 to the 8th divided by 10. So now I have to take 4 and 2 tenths and divide it by 10. So can 10 go into 4? The answer is no. Can 10 go into 42? Yes, 4 times. Can 10 go into 20? Yes, 2 times. And now we're there. Okay, so now this number, when we converted it so that it has the same place value, we now have 0 and 42 hundredths times 10 to the 8th. And what we're going to do with that is subtract it from 2 and 1 tenths times 10 to the 8th. So now our powers are the same, so all we have to do is subtract. So in order to do that, I'm going to line them up. So 2.1 times 10 to the 8th minus 0 and 42 hundredths times 10 to the 8th. Okay, and I can fix this by saying this is to the hundredths, and now I'm going to subtract. Our powers stay exactly the same, right? And then we subtract. So this would become a 0, this would become a 10, 10 minus 2 is 8, this would become a 1, this would now be 10, 10 minus 4 is 6, and then we'd have 1 minus 0. So we got 1 and 68 hundredths times 10 to the 8th. And that is your final answer for subtracting. Okay? So that wasn't too bad, right? The biggest thing that you have to work on is getting your powers to be the same, okay? And hopefully by seeing how we moved that place value, you were able to see how that we could correctly show what the values of the numbers are so that you could get your place values lined up and then actually add or subtract, okay? All right, so I have 2 practice problems for you. The 2 practice problems that I want you to try without me are 1 and 5 tenths times 10 to the 2nd power plus 7 and 2 tenths times 10 to the 5th power. So looking at those exponents, your first job is to decide, are you making this 10 to the 5th or are you making this 10 to the 2nd? You have to decide what you want to do. Then the other practice problem that I have for you is 9 and 8 tenths times 10 to the 3rd power minus 9 and 8 tenths times 10 to the 7th power. So again, which one are you going to change your place value for, and then subtract, okay? So I want you to have fun with it. If you get stuck or you get confused, go back to what we did over here and look at your examples, because we did both types to help you see it, and it should be pretty sensible when you're done. So our goal for today is we will learn how to add and subtract scientific notation, which is what we just did. What must the exponents be in order to add or subtract scientific notation? The exponents have to be the same power, okay? And if they have to be the same power, then you're going to have to change the place value of one to match what the power is of the other, okay? All right, kiddos, that's all I have for you in this lesson. I'll talk to you soon. Bye!